So we finally made it to the final lesson for this coding unit, lesson 10. So let's take a look. By now you've defined a function called distance. The four inputs are numbers that represent the player's x and y coordinates, which we are calling px and py, and another character's x and y coordinate, which we are calling cx and cy. So when we calculate the distance between 2 points on a graph, we use the Pythagorean theorem. And you had some practice with that in your most recent homework assignment, the lesson 9 homework. When the computer calculates the distance between 2 points, the computer uses the distance formula, which is what we practiced in lesson 9. I want you to be aware that the Pythagorean theorem and the distance formula are essentially the same thing. So not only are they mathematically similar, but they actually are calculating the same exact thing, the distance between 2 points. So let's recall the Pythagorean theorem was a squared plus b squared equals c squared, where a and b are the two legs of the right triangle that you have drawn on graph paper, and c is typically representing the missing piece, the missing distance between the two actual points. And the distance formula, which is, remember, x2 minus x1 squared plus y2 minus y1 squared, and the whole thing has the square root taken. So those are our two, essentially the same types of formulas that are calculating the distance between 2 points. So let's take a look at the next 3 examples. Example 1, if the player is located at 320, 240, and the danger is located at 400, 160, the distance can be calculated by evaluating, and this is given to you in this case, but by evaluating distance 320, 240, 400, 160. So that's the x coordinate of the player, the y coordinate of the player, the x coordinate of the other character, and then the y coordinate of the other character. What the computer will actually compute is the distance formula. So we see some similar code here that we went over in lesson 9, where what we're asked to fill in are the 2 inputs for line length here and 2 inputs for line length here. So we have to keep in mind that we want to keep the x's together. So the 320 and the 400 need to be together because we're calculating the distance between them, the distance between the 2 x's. And then separately, the other line length function needs to calculate how far apart the 2 y values are, 240 and 160. So I'm color coding this again so you can see that even though the 4 inputs are in a specific order, the first and third represent the x's, which have to go together in the line length function. And then the second and fourth represent the 2 y coordinates, so those have to go in the other line length function. We still see the squared and the squared, which are part of the distance formula. We still see the addition, or the sum, which is part of the distance formula. And then, of course, the square root is the final function that takes place when we use the distance formula. So I'd like you to go ahead and try examples 2 and 3 on your own. They're very similar to example 1, so if you want to take a look at that as a hint, go for it. Otherwise, pause the video now and try example 2 and example 3. Here's what example 2 and example 3 should look like. Keep in mind the x's should be paired together in the line length function, finding the distance between the 2 x's. And then the 2 y's should also be paired together in the other line length function to find how far apart the y's are separately. So hopefully, using example 1 as a guide, you were able to successfully do examples 2 and 3 on your own. Let's take a look at the bottom of page 1. Now that you know how to compute the distance between 2 objects, you need to decide when 2 objects have collided. We discussed in lesson 9 that if your characters are 2 circles, then the 2 circles will overlap or collide when the distance between their centers is less than the sum of their radii. So as a general rule, what we're going to find is that 50 pixels is usually a sufficient distance for detecting collisions between your player and danger or your player and target. So in other words, the 2 characters do not have to be on top of each other for them to be considered collided. Within 50 pixels is typically enough for the characters to look like they have run into each other. So either your player has collided with the danger and you'll lose points, or the player has collided with the target and you'll get points. So in number 3, what code would allow the computer to check whether the distance between 320, 240 and 400, 160 is less than 50? So we're being asked, first of all, to write the distance between these 2 points in code. So that's actually where I'm going to start. If I wanted to find the distance between 320, 240, and 400, 160, I would write it like this. Distance requires 4 inputs, 4 numbers for the inputs. And if I wanted to check to see if that distance is less than 50, I would use my less than function out front, with parentheses of course, and less than 50, the 50 would have to go all the way at the end here with closing parentheses. So that's the code that we would be using to basically ask the computer, are these 2 coordinates, are these 2 characters less than 50 pixels apart? Are they close enough to collide? So if you go ahead and go to the next page, we have finally made it to our last design recipe for our coding unit, which is called the collide function. So let's take a look, and hopefully at this point we find that we're experts at writing a design recipe. The directions here say write a function collide with a question mark, which takes 4 inputs. Again, our 4 inputs are px, py, cx, and cy. The x coordinate of the player, the y coordinate of the player, the x coordinate of another game character, and the y coordinate of another game character. So these variables hopefully make sense. So for our contract, the function name is collide with a question mark. The domain says that the 4 inputs are the 4 that are given here. Those are actually the same 4 inputs that were for our distance function. So the domain is actually the same. Number, 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 number. But this time our range, it says what the function is supposed to do. Are the coordinates of the player within 50 pixels of the coordinates of the other character? So I kind of want to reword that there. AKA, are the characters less than 50 pixels apart? We want to know, are the characters supposed to collide when they are a certain number of pixels apart? So since that question is really asking a yes or no question, or a true-false question, we're going to find that the range here is actually a Boolean. We're actually going to get true, the characters are less than 50 pixels apart, or false, the characters are not less than 50 pixels apart, meaning they would not collide. So for the purpose statement, I would say this function checks to see if the coordinates are close enough to collide. So I've written down my purpose statement here, and now we are ready to do our examples and our definition. So once again, I've already written out the first example for you. So the first example says collide 100, 200, 300, 400, 4 made up inputs. The computer is supposed to check, is the distance between 100, 200, 300, 400 less than 50? So I believe at this point that you should be able to pause the video now and fill in the second example on your own without peeking. So go ahead and do that now. So here's what our second example will look like with these 4 made up inputs. Is the distance between 150, 350, 600, 500 less than 50? So when we go to define our collide function, once again, our 4 inputs are px, py, cx, and cy. And we're trying to find, is the distance between px, py, cx, cy less than 50? Again, the way this function works is if the answer to that question is true or yes, then the characters will be considered to have collided and the points will reflect that. If the answer to that question is no or false, then the characters will be considered to not have collided. They are far enough apart that no points are awarded and no points are taken away. So this is our final design recipe for our video game. The rest of this page has you insert this design recipe and this code into your video game, and at the end of this page you'll find that your video game is actually playable. It's actually fun to play. You'll get points when the player and the target collide, and you'll lose points when the player and the danger collide, and the point is to not get your points all the way down to 0. So finish up this page, get signed off, and you'll be ready for your final assignment for this unit. That's the end of this video.